Hello everyone, it's December the 3rd. Alright, this one, we done it a few days ago, but I kind of forgot. I had a vague memory of how I did it. Oh, by the way, yesterday I saw that LeetCode has a VS Code plugin. I'm not sure if I want to do that. Maybe I should try just to see how that one works. Especially given that these days I have so slow loading right from the website. So maybe it's a good idea to try the plugin. But I read out the plugin, like the issues, and they have some issues with login. So I don't know. Maybe it'll turn out more troublesome than the current system I have. Anyway, yeah, I think that's the one we've done, right? We done it. Oh, hold on. That's not the same one we done. The ones that we've done just a few days ago, this is more than a year ago. It's slightly different. Oh, that's a new question, basically. Given an integer array, find a continuous non-empty subarray within the array that has the largest product and return the product. Wait, what was the problem? Oh, the problem I done was the maximum product except for one. That was the problem that I done. This is different. This is a contiguous subarray, right? That's slightly different. Can we use Cardane for this? I'm not sure. I'm gonna try. So what's the example? We have 2, 3. Ooh, we have minus 2 and 4. So at 2, we say ending at 2 is gonna be 2. Ending at 3. So we either by itself or we multiply, so it would be 6. And then minus 2 will be by itself, or it will actually be minus 2. And then 4 will be by itself. So that's 6. Minus 2, 0. Yeah, isn't this just Cardane? Like Cardanes, but instead of sum, we do multiplication. I'm gonna give it a shot. See if it's Cardane. If it is, then that one is actually quite straightforward, should I say. Okay, here we go. Max product. I don't think we need a deck. So it'll be like an edge case. I'm just thinking like a 0, right? If it's 0, I can always multiply because, well, if it's a 0, it's actually going to be 0 no matter what. Yeah. Okay, so we're going to say res is equal to, I don't know, nums1, nums0, right? And then we're going to say for, actually, let's go, that's fine. And I'm going to say for n in nums, for 1 to the n. Oh, we need a pre. So res pre is both equal to this, right? So for n, I'm going to say basically when choose the bigger one. So say what I will do is either I multiply by pre or I by myself. So I'm going to say pre equal to the max, either I by myself, so I don't multiply, I start myself, or n multiplies pre, right? So I pick the bigger one, and then res equals max, res and pre. And at the end, we return res. Let's see if this, I mean, we have only 2 test cases, but we can try it. So it's 2, 3, minus 2, and 4. Okay. This one gives us 6. Second one is minus 2, 0, and minus 1. This one shall give us 0. Max product. Okay, these two work, but I don't know. I'm gonna run some random case. Oh, I can only run minus 10 to 10. Okay, so let's say minus 1, minus 2, minus 3, 4, 5, 6, minus 3, minus 2, 5, 6, 7, minus 5. Right? So, yeah, some random string of numbers. Alright, this is not right. Oh, that's the difficult part. Oh, I see. Yeah, I was like, this is too simple. Yeah, now I see. I see how this one goes. The negatives. That's the difficult part, the negatives. Because as we go, right, we can actually go this out. We're going to print each pre so you can kind of see. So we're going to say n and pre, right? Minus 2, pre is minus 1, so I will get 2. And this one's a minus. Minus 3. As I multiply, it will be minus 6, right? So I say I'll take minus 3. That's why it can only add up to 180. Because I can, with all these minus, and all these minus, oh! Maybe we should check on the positive and the negatives. I mean, the whole thing is about multiplying, right? So if we're multiplying, if we have even numbers, if we have no 0, if we have no 0, and we have even number of negative values, they shall be added together. Or we don't do, we just what do you think? Well, I think maybe we should keep 2, right? We have a positive one and a negative one. Let me think. So, what are you saying? What I'm saying is every pair of negative values will come to positive, right? So if that's the case, we shall keep multiplying, and in the hope that if we can have, so basically we say at this point, right, what we want is maximum, well, but at this, the maximum shall be these multiplied together, right? So at this position is going to be 2, that's fine. And this position, it can be 2, because I need to involve myself, right? If I involve myself, it's either minus 3 or minus 6. Like if it's, if it's minus 1, minus 2, minus 3, that should give us 6. And I don't think mine can do that. Let's solve this problem first, right? So how? This means that if it's a negative value, right, we shall keep, when these multiply together, we'll have a 2. And definitely, if we say it's minus 1, minus 2, that is a 2. Yeah, we can get that. But the thing is with -1, with this minus value, we shall keep two. One is the minus, right? So we're gonna have something maximum. Simplify, if it's a positive value, all right? If a positive value, and I look to the value before me, and the value before me can either be positive or negative. If the value before me is a positive, no question, we just multiply by it, that's it. If the previous value is a negative value, then we have a question, all right? So I can either multiply it, so I get a negative as well, or I can keep a positive. So I have two, right? So I have two. One is negative, one is positive. So in this case, it's -1, I only have -1. It doesn't have a positive value. And for -2, I can keep two values. I can actually say its positive value is 1. Well, actually, I cannot say its positive value is 1. What should its positive value be? There's no positive value if it's -1. But if we want 2, then that's -2, right? And this one does not have positive value. That's fine. That's fine. That's if it's none. We're just gonna set it to none. Then we don't do it. And for this one, its that we will have positive value is 2, and negative value is -2, right? So the positive and negative value is based on what is in the front. So now I have two values. And then we can actually start from here, right? We can actually start from here. I have two values. And for this -3, I will look for, because I have minus, right? So I want to, and I have a positive, then I get a more negative value, or I have a negative here, -2, to get a positive value. So I always get 2. Oh, so either you go more negative or you go more positive, right? So you always have two things going on, either more negative or more positive. Okay. So everything we try to either go more negative or go more positive. What about 0? Well, if it's a 0, then if it's a 0, we reset, right? If it's a 0, then we reset. Because we know we cannot cross the 0. So if it's a 0, we just redo it. Okay. Okay. So, what do we do? Well, we're gonna always have if it's a 0, hold on. Rest equal to this. The pre equals to, I need two values, depending on whether it's positive or negative. We can start with none and none, right? And say if it's, looking at it, if I am a negative value, right? And then if both are none, if it's none, then it's going to be me. Okay. Let's use named tuple. So from collections, import named tuple. So basically what we're saying is res is math.inf, right? Yeah, let's do this one, import math. And then we're gonna say the element will equal to named tuple element, and we have two values. One is positive, the other is negative, right? Now, for nums in this, and pre equals element none and none, right? So we're coming in for any nums. If n is 0, right? If we have a 0, then res equals max, res is 0, and then we reset. So pre equals element none and none. Now, because it's a 0, we always reset it. Else, right? Else. Now we're gonna see we have a value, and we say if pre dot pos is a none, right? If pre dot pos is none, then if pre dot pos is none, and hold on, how should we do this? So what is the current? Right. Current pos and the current negative, both are none and none, right? We'll just start with this. We say if pre posit is none, then current positive shall be none if n is smaller than 0. Else n, right? And if pre dot negative is none, then current negative equals none if n is larger than 0, else n. If they're neither are none, right? Neither are none. Hold on. No. This feels convoluted. So what do we want? So we have a pre, and we have a none or something, or we have two values, right? Then if any one of them is none, if the pre-positive is none, that means I will not get, I will get a positive, right? If I'm negative. So no, that's not how it's done. So I have the current value as n, right? Okay, hold on. Let's do this again. Now I have a current value as n. And if n is larger than 0, yeah, if n is larger than 0, so n is positive, then we can say pre can equal to element, right? So if I'm positive, then I look for pre-positive. So we say pre dot positive times n, right? If pre dot pos is not none, or in other way, we can say this is going to be none if pre dot pos is none, else this, right? Otherwise, and the result will always be, I shouldn't say always be positive, because the result can be negative, but as long as I have two values, it's not going to be. So actually, yeah, let me put these on as well. So one value, negative value, right? So that's the positive. Negative, we're gonna say none. Well, hold on, because I'm positive. If the previous one is hold on. If pre is none, then it just be n. If pre is none and I'm positive, so I will take the place. Else, the pre deposit is not none, so I just multiply. Otherwise, right, for the negative, say if, right, it's pre dot neg times n if, no, we say pre negative is none. If pre-negative is none, then I'll be none. If pre.neg is none, else pre.neg times n. Boom. That's the pre. Right? So we update the pre. Sounds weird. Let's not call it pre. I don't like it. Let's call it current. Right? And then we have the current, and then we need to check the res. So res equals max res. Oh, and also it could be none. So res current dot positive, current dot negative. If I can do this at the end. I can do this at the end. There could be none, right? How do we handle it? So we have to do another one. Then just don't put none in there, right? Don't put none in there. We just put a large negative value, minus math.inf. That's the only thing we need, minus math.inf. Right? That's it. That's what it is. It's just so say if this is equal to, right? It's a flag. Basically, it's a flag, and we say this. If this is equal to this, right? And then with that, I can do that at the end. Alright, so the positive and negative both, I just use this and it can help me do this. So res equals max this. Else, this one is n is smaller than 0. So basically we do it exact the same thing, right? So we do it exact the same thing. Now, n is negative. So if the positive is a none, then I will become none, right? Otherwise, if I have positive, has something, then I don't multiply. Because I multiply, I become negative. So I just leave as is. If the negative is a none, then I will do myself. Else, oh, hold on. That's actually not right. So the first one is positive, right? So the positive is if the negative is none. If negative is none, then the positive will be nothing because the previous value is negative, does not exist. And I am negative, so there's no way I can create a positive, so it's nothing. Otherwise, I can do current.neg times n. That's a positive value. Else, I'm going to say the positive. If the positive is nothing, then it's going to be myself. Otherwise, if the positive is positive, then it's going to be positive multiplied by n. Right? And we do this, and we do the rest again. Right? So after all this, and we're just going to keep going on until we finish. Let's try this one. Okay, so we pass these. We pass everything. Seems like that is the case. Can we make it a little bit better? How should I make it better? Like these two, can we combine them? I want to like do this one, but this is an issue. Basically, we're just going to do res. Now, let's just do it this way. Yeah, we see the thing. You want to try? Let's try another test case. Okay, then we just randomly just add some negative sign. Okay, another one. Oh, shoot, it's too big. Alright, let's try it. Yep, there we go. Have some confidence, man. Oh, and then look at this. We have this answer is 48. So this is actually slow. Well, I mean, I am using the name tuple. Oh. I like name tuple. I want to use more name tuple from now on. It just, how should I say it? It makes things clearer. So 152. Well, I thought it was a, yeah. I thought it was a straight forward Cardane algo, but it turns out, there is some work, right? There is some work to do with regards to accumulating the negative and the positive. We cannot just keep tracking the positives, because if we have a giant negative previously, multiplying it with another negative will give us a giant positive value. Thus, we need to keep track of both negative and positive product of subarray ending at each position. Another trick is to handle the case of 0. Whenever 0 occurs, we basically have to start all over again. So this one goes on and it runs in 64 or a 32%. All right. So first thing is trying to see if there's any change in test cases. So let's go this one and myself. All right. $187. Same, so this one is faster. Oh, oof. A helper. A recursion. 0 position. Cumulative product. I got cumulative product. And then so if it's 0, we append 0. If it's previous equal to 0, we append, that's restart, yes. Otherwise, so I got cumulative product. And then what? Then 0 positions. Max helper start. So 0 index -1. Okay, so basically we're trying to compute, so we divide it into different sections. Right? Each section is split by zeros. And within each section, I'm going to compute the maximum. How do I do that? I say if this n larger than 0, we return the n. That is correct. That is correct. If start is larger than end, because if we keep moving forward, then we return start. Otherwise, result equal to this divided by start. Yes, that's the current. So the rest, and then for I in range, start plus 1 and end plus 1. We're gonna do the same thing. Rest, cumulative product, I minus 1. Why I minus 1? And end divided by I. That's the remaining sum, the remaining product. This is the cumulative product up until this position. I guess it works, but terrible logic. I have another one. I suppose this one is the good one. Ah, yes. Min max. Min is current min times this. Temper max, current min, current max. Ah, easier than how I was doing it. Okay, how do they? So I keep track of the current min, and I keep track of the current max, because the current min can become current max. Oh, all three of them. Yep, it's I was close. I was close, but not the best. I was close. This is exactly what I was doing. I was keeping track of the negative values, right? So this is just keep tracking the more negative, keep tracking the more positive, and we do the max. And I just realized, wait, the max allows to do this? Oh yeah, it does. You can just keep putting things inside. It works. Which means this one can be updated. I shouldn't say it's the min max, current min, current max. Well, I'm not gonna write it, but update the solution I had. The second solution, right? The second solution I had more than a year ago is the same idea, has the same idea, but with much better implementation. Actually, let's do it. Probably won't submit it because there's no point. This is the exact same thing. But I want to record it. This is improvement, right? From the first time I was trying on this. At least this time I got it. I got the idea. So this is the same as the second solution I had a year ago. It has the same idea, but with better implementation, right? All right, let's now look at it. Turn this off. All right, so rest current mean, current max, keep tracking on this, equals nums 0. Oh, in that case, I can actually just say minus math.inf, math.inf, and minus math.inf. And we say for any nums, right? We say temp min equals minimum current min and minimum current min and what? So I want to find the minimum value. Shouldn't be current min. Well, current minimum multiplied, if n is positive, it's going to be current min multiplied by n. If n is negative, then it shouldn't be current max. Hold on, let me think. It doesn't really matter. I think I could directly say current min shall equal to the minimum of current min, right? Current min times n, and current max times n. And the current max is a max current max, current min times n, and current max times n. And res equals the max of res and current max. And then return res. Nope, this is not right. We got infinity. How? Oh, because current min is math.inf. Okay, so I cannot do this. Okay, let's do nums 0. Nums 0, nums 0. Oh, I can actually do this. I can do this one equal to. And this one I'm going to go start from 1. Try this. We pass some, but we fail some. Oh, interesting. Oh, because current min is already computed. Maybe this one will work, right? Because this will compute them. This will not first compute. Now I think it's still. I don't like it. That's why. Hold on. So basically, say temp min is current min times n. Temp max is current max times n. Current min is going to be minimum of temp min and temp max. That's my understanding, but I feel like this is. Nope. This should be the true mean value. But it depends, right? If n is a negative value, and this one will give me more negative. It shouldn't be current min. I have to compare to this one as well. The result is 24. How? It's 2 times 3 and then times 4. Oh, I skipped. Why would this solution skipped? Maybe I shall do this. Current max times n. And this will be maximum of this current min times n. No. Hold on. So everything start with 2, current min max, right? And here, and when the current min is 6, current max is also 6. They're both 6. Now coming in here, oh, current max at this position is what? It's not 6. Right? Current min is minus 12. But current max is minus 2. Right? It's minus 2. Ah, I see. That's the problem. So I have a temp min, right? Shall equal to minimum of this, maximum of this. I think this one only needs temp min, and this one only needs temp max. Okay, still not right. We still have these. So temp min equals current min is 6, current max both are 6. That's a negative 2. And current max is negative 12, and minus 2. So temp max shall be minus 2. So I'm going to do current max, right? Current max. Oh, aren't these already current max? Yeah, this is already current max. I don't have to do this again. Yes, because the temp max is minus 2, but the current max is, the temp max is already. So in that case, I do think we can just go current min, current max equals this and this. There we go. Yeah. So current min is current min, current max. Now we multiply, and then we compare this also to n. That's the key part to get the min value at the current point, the maximum value at the current point, and then we assign. Yes, this one makes more sense now. So it's different. It's slightly different from my previous. The syntax, right? The syntax is slightly different. Okay, pretty good. All right, so that's that. It took us longer than I would like. I thought this one will fly through this. But current min and current max. That makes sense. All right, let's endeavor another one. LeetCode curated SQL. Jeez. I don't want to do SQL again. What else? Top Amazon questions. Now we can win badges by complete study plan. Yeah. What's that? LeetCode's pick. Start creating. Interesting. Okay, medium. Yeah, we're gonna drill out as many mediums as possible. maybe next time I can, because what I notice is the slow speed all happens during the streaming. So next time I can just open the window here to get the one already, so I don't have to go through this process. It's a very slow process. I think I clicked it and didn't respond. Okay. I think it's the 4th page. Oh, I have 23 pages to go. That is a lot. Okay. What do we have? We have number 319, bulb switcher. For light bulbs, I guess. Switch light bulb. Bulb switcher. Wow, a lot of dislike. Bulbs that are initially off. You first turn on all the bulbs, then you turn off every second bulb. On the third round, you toggle every third bulb, turning on if it's off, turning off if it's on. For the ith round, you toggle every I bulb. For the nth round, you only toggle the last bulb. Return the number of bulbs that are on after n rounds. Hold on, so for the ith round, you toggle every I bulb, and for the nth round, which I guess is the last round, you toggle only the last bulb. Okay, so n equals 3. First round, everybody's on. Second round, every second, you toggle every second, so 1 second, okay? So 1, 2, 3, we'll toggle this one. 3 bulbs are, so you will turn 1, okay? That's it? That's all the examples? Okay, I need to see 4. Actually, the n round. Wait, how many light bulbs are there? N light bulbs. Oh yeah, then for the nth round, you only toggle the last bulb. Yeah, because that's the nth bulb. N is 10 to the 9th. Oof. Okay, so 10 to the 9th. So the first round, everybody on. Let's do 5. Let's do n equal to 5, right? So second round is all the even position. So even position becomes 0. Third round, all the 3s become 0. So 1, 2, 3, 1, 2. And then the fourth round, the fourth one, toggle back. And the fifth round, so 5 shall equal to 2. Let's see if I understand this question right. Equal to 2, 5. Yep. All right, hold on, I'll be back. All right, a few properties, right? So one of the properties is after you toggled, let's given a 5, right? After I toggled the second one, and the second one will remain toggled. It will not change because each subsequent toggle will go further down, right? Will go further down. So everything that has toggled already will stay as is. So that's one identification, which means all the prime numbers, all the prime will remain toggle, will remain off, right? Will remain off. Now, for all the others, so basically we're saying, so and the first one will always be on, right? The first one will always be on. The second one will always be off. The third one will always be off. And the fifth one will always be off. But the fourth one, I'm going to toggle it once, because on the 2, I toggled it. For the 4, I toggled it again. And that's it, all right? So for each position, so for all the, hold on, let me do this again. For all the even positions, right? For all the even positions will be 0 after the first toggle. Yeah, I'm trying to see number 6, right? And then for number 6, 2 will toggle it off. 3 will toggle it on. Right? 4 does not change. 5 does not change. And 6 will toggle it off. Right? Because 6 equals 2 times 3. So it's prime factor. Right? Prime factor. So given any value, let's say 7 will always be off because 7 is a prime number. So given, like, let's say 14, right? 14 equals 2 times 7. So 2 will toggle it off, and 7 will toggle it on, and 14 will toggle it off. So that is going to be off. But if we say 28, 28 is 2 squared times 7, so it's a factor for 2, factor of 4, and 7, and factor of 14. Oh, are you trying to analyze everything? Doesn't seem to be wise. Yeah, so we have 2, 4, 17, and then 2, 4, 7, 2 times 7, 4 times 7, so 28, right? Let's see, that 1 has 4, no, it has 3, so it's 2 to the 3, 1, 2, 3, 4, 5. 2, 2, 7, right? So we have 1, 2, so we have 1, 2, 3, 4, 5, 6, 7. But we have duplicates because it's 2. So 2 have duplicates. 2 is just 2 by itself. So I have 2, 4, 7, 14, 28. So as 1, 2, 3, 4, 5, it's 5. It's an odd number, right? If it's odd number, it's going to be toggled off because it's off, on, off, on, off. If it's even number, off toggle. Like 4. Right, 4 equals 2 times 2. So we have 2 and then we have 4. And of course we have 1, right? So yeah, we can add 1 as well. So if it's even number of unique factors, that's going to be a 0. If it's odd number, that's going to be a 1. Okay. How are we going to find every single one? We can't. It takes a long time to factor everything. I mean, take the 10 to the 9th, right? That's going to time out. So every value you want to find the total number of factors. It's also prime number related, right? So if 6 is this, 7 is going to be this as well. 8 can be toggled by, so all the powers, right? 8 is 2 to the 3rd. So we have 3 different, so 2 hits it, 4 hits it, and 8 hits it, and also 1. So that's even number. If it's even number, that's going to be a 0. 1, 2 off, 4 on, 8 off. And what we're trying to see is who will remain on. $14 will be on because I only have 3. So all the triple will be on. Well, adding 1, and it means it's two unique factors. No, even number of unique factors. Huh. Is there a way to compute? Is there a way to compute? I need help on the math. Find unique. But even you find unique factors, there's so many of them. 10 to the 9th. We have 10 to the 9th. How are we going to handle 10 to the 9th? Like 10 to the 9th, like ON is going to be too slow. So what's the value for 10 to the 9th? A giant value. 1, 2, 3, 4, 5, 6, 7. That's 8. Yeah, it's not that large. So the ones that will remain on is very limited. see if I can find some. Seven is going to be 0. Okay, let's start from 0. 1, 2, 3, 4, 5, right? So 0 is going to be 0, 1 is 1, 2. 2 is 1. 3 is 1. 4 is 2. 5 is 2. 6 is 2. 7 is 2. 8. Well, 8, we find out 8 is going to be even number, right? 2, 4, 8, 1. So 8 is going to be 0. So that's also going to be 2. For 8, wait, is 8? Oh, hold on. Well, 8 is 1. 8 will have 2, 4, 8, and a 1. So on, off, on, off. Shouldn't it be off? 1, 0, 1. Oh, these are all ones. Jeez. My bad. 0. Yeah. 8 is 0, right? 9. 9 is 3 and 9. So 2, 3. So 9 will be on. 9 is the same as 4, right? So 9 will be on, which means we got to 3. 10. 10 is 2 times 5. So 10 will be on as well. Hold on. You're saying, let me see if I got this right. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 will be 4. Right. Right. Copy this whole thing, and I need a new just to see. Alright, so 0, 1, 1, 1, 2, 2, 2, 2, 3, and a 3. 10 is 3? How is 10 3? Oh, 2, 5, 10. Shoot, 2, 5, 10. 10 has, 2, 7. We always have a 14 as well, so these are 4. Oops. Oopsie daisy. That was wrong. So 10 is off, so that's 3. $11 is off, because 11 is prime. No. 12, how about 12? 12 is, 2 and 3, right? So, how many does 12 have? 12 has a lot. That's 2 to the 2 times 3. So, I can remember it's going to be the number of unique factors. Hold on. The number of, I still can find unique factors. Number of unique factors of an integer. There's some, I think, some Euler's formula for this. Number of factors. Number of unique prime. No, it's number of total factors. where p, q, r are primes, positive integers. If n is a power of a prime, then it has alpha plus 1 factors. If n is a power, it has alpha plus 1 factors. Yes, every prime in the prime number product rules those together. Okay, so yeah, that makes sense. So what we have is, I think for 12, is 2 to the second times 3. So what we have is going to be 2 plus 1 times 1 plus 1, right? So that's 3 times 2, that's 6. So 12 will have 6 unique factors. And that's 6 unique factors including 1. Yes. So if I have 6 unique factors, I see. You see that? Because everything's plus 1, the only possibility to make this a even number, no, an odd number, because if it's even number, it's going to be off. The only way is to make this an odd number, and the only way to make this an odd number is for alpha, beta, gamma, all these powers are odd. So everything has to be odd to make it work. Right, so this has to be odd, this has to be odd, which means alpha, beta has to be even, right? Alpha and beta and gamma, they all need to be even. Okay, so they all need to be even. So we need to say, so it has to be p to the 2n, right? And q to the 2n. Well, that's actually not 2. Let's just say 2 alpha, 2 beta, all the way to gamma. No, that's r to the 2 gamma. That is the only possibility, right? Because all the time odd is odd. Okay, so now the question becomes, how many of these numbers exist, right? In the range from 1 to 10 to the 9. How many? Well, this is going to be a lot. Like how do we find the total number? And we have all the prime numbers. So it's, all we can say, it's the prime squared alpha q squared beta times gamma squared gamma, right? So for all the prime numbers, we can just square them, okay? If I square them, but hold on. No. 1, so 1 is the one that make it, because if it's 1, so alpha, beta, everything is 0, right? Well, now I can say alpha equals 1, and then beta is 0, so that's 4, right? So basically, what we want to find out is the maximum I can get, the maximum prime. How many primes are there from 1 to 10 to the 9th? How many prime numbers? Once we found how many prime numbers, right, then we can line them up, and then on the power we just play around. But we also need to know when they're going to blow up. So they have different combinations, right? I can go 1, right? And I can say the first is 1, the second is 1, so 2 1s, 3 1s, the different combinations. Hold on. So we say it's 4 to the alpha and 9 to the beta, right? And then 25, 49, let's say A, B, C, and D, right? So that's the starting 4 prime numbers. And then given the current range, let's say 100. So we're going to find all the prime numbers that go to actually 100. So give us 10. So 49. That's it. That's 49 is the largest. We go to 100. Okay, so if we go to 100, I have these 4. Then what? Then I say we're gonna multiply together, right? So everyone take 1, so that's 4. And then we can say wow, that's two ones? 2 1s. Hold up. Let's say A equals 1. Right? A equals 1. B is 0. C is 0. D is 0. That's good. Right, so A equals 1. B is 1. C is 0. D is 0. That's good. A equals 1. B equals 1. C equals 1. That blow up. Right? So we stop right here. So we have 2. Now, A equals 1. No, actually, no. Wait, hold on. Everybody is 0. Let's say D is equals 1. So everybody is 0. That's 1. And then D equals 1. That's 2. Now D equals 2. Boom. Blow up. Cannot do. So now C equals 1. D equals 0. Right? C is 1. D is 0. That's 3. And C is 1. D is 1. Boom. Blow up. Cannot do. Now C now C equals 2. Yeah, okay, so that's like C equals 0, D can go 0, 1. C equals 1, D can go 0. That's it. And C equals 2, blow up, cannot go. So now I'm going to go B equals 1. Right? Now B equals 1, and C is 1, C is 0, D is 0. That's another one. And B is 2. Now B is 1, C is 1. Boom, blow up. Cannot do. Right? So cannot do. So B is 2, C is 0, D is 0. That's another one. That's this, right? And B is 2, C is 1, blow up, cannot do. B is 3, cannot do. So now we go to A is 1, right? A is 1. B is 0, C is 0, D is 0. Can do. A is 1, B is 1. We can do. Oh. We can compute all the values that's viable, right? Hold on. All the value that's viable. So for the D, we say it's gonna be 49, and for C, right? All the possible values for C is going to be 25, right? That's it. That's only D by itself, C by itself, right? So C by itself is going to be 25. Now B, we can have 9, and then we can have 81, right? And that's it. Now we'll go to A. A, everybody can have 1, right? Everybody can have 1. So A, we have 4, and we multiply by the smallest. So 4 multiplied by smallest, 4, so we add 4 in. Now actually, hold on. So 8 and 4. We need the next smallest. Next smallest is we push 4 in, right? So we pop 1 out, push 4 in, so 1 can go to the other one, right? So we push 4 in, now we pop 4 out. 16, right? 16. So we pop 4, 16 goes in. And then next one, 9 pop out. Hold on, let me do the one more time. So the first one we go from the largest, right? So we have 49. That's the first one. Okay. So 1. So we start with 1. And then we're going to pop 1 out. It's 49. And then 49 push in as well. So now we have 49. But then we need to put 1 in there as well. Now 25 comes out. So 25 we can pop out 1 times 25, 25. So we'll push 25 in. Right? And the 1 we save somewhere else. And then now we're going to pop 25 out. We blow up. So we can now do. Now we add 1 back. Now 9. So pop 1 out. 9 push in. Pop 9 out. 81 push in. 25 pop out. Cannot do. Okay? So in that case, then we push 1 and 9 back in again. Now for 4, 1 pop out. We get 4. Right? So 4 push in. 4 pop out. 16 goes in. Right? Now 9 pop out. 36 in. 25 pop out. 100 goes in. Oh, actually not 25. 16. I have to pop out 16. 16 pop out. 64 goes in. Now 25 pop out. 100 goes in. Next one, 36 pop out. Boom, explode. And that's it. So the total number is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That is going to be 10. So if we do 100, with 100, I say this is going to be 10. Yes, it is 10. It is 10. But how long is this going to take? Well, I mean, 10 to the 9th, right? So we go 10 to the 9th power. The prime number will go at most to the square root of this. The prime number will go to 31622. 31,000. That's a lot of prime numbers. And so it's 31622. That's square, right? So basically, given an n, we can use sieve to obtain all the prime numbers that are smaller to a certain value. Then we square root them, right? Now after we square root them, we're going to use this technique to find out how many different combinations we can get out of them, given that we are wow, this is how's the runtime going to be? 30,000, right? At most 31,000. Okay, so we go 31,000 times, and each time we are going to go through a log. Like, oh, unlog it. Maybe. Yeah, let's try. Let's try. This is going to be, it's going to be very interesting. Yeah, I'm not sure. This one. So we need to first obtain all the prime values. And definitely we are not going to copy some prime values. We're going to sieve it. Okay? We will sieve it. And of course, if this doesn't work, we're going to check the answer. That will be 2 days in a row. We failed 2 days in a row. Let's hope this not happen. So we're going to sieve it. How do we sieve it? So we need math, right? So we say import math. So we need the upper limit. So lim equals int math.sqrt, and this is our limit, the maximum value we can hit. So to find the prime values, the prime numbers. Okay, so sqrt this. Let's do this +1 then. How do we sieve it? Well, we sieve by sieve equals 1 times lim +1, right? So that's the total. And then we first take away, all the odd. So actually we can do that while we are doing this. I think we can already handle it. So we can say, right, for this for I in range lim +1, right, and we say it's going to be 1 if I 2 else 0, right? So all the even values will be 0, but sieve 2 will be 1 because 2 is a prime number, Now we're gonna say for I in range 3, right? 3, 5, and wait. So we go through all the all the odd values, right? And if this odd value is a composite number, then it's already sieved. So if it's a composite value, do we? Well, we do that as well. So we say from 3 to what? To what? Well, I think it's the SQRT limit, right? It's gonna do to SQRT limit because I don't have to. Well, why did you do that? I just say I equals 3, right? We say while I squared is smaller than lim, then for j in range I times I, right? And we're gonna always go the same. So I times I all the way to lim plus 1, and the interval is going to be I times I. So for j in this, sieve j is going to be equal to 0. After we're done, I plus equal to 2. And let's print the sieve. We need to obtain the prime. So the primes will equal to I for I in, no, for I s in enumerate sieve if s. So let's print prime. I haven't written this for a while, so I'm not sure. Okay, 0, 1. Oh, so I have a bunch of test cases. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. No, I don't have 11. So it's 1, 2, 3, 4 is 2, 5, 6, 5, 6, 7, 8, 9 is 3, 10 is 3, 11 is 3, I don't know 12, but I know 100 is 10. Okay, that's my test cases. But now I'm just handling, I just need 1. And now I'm just handling, actually, let's do 10. So this is n, bulb switch n. So I just want to find out. Alright. That is actually not correct. First of all, 1 should not be in there. If s and I not, oh, I just need to, so we set this, and then we set the C1 equal to 0. Okay. Why would 11 be there? Lim is 11. Okay. Lim is 11. Maybe we shouldn't. Maybe we should just, right? And then there will be only 7. Okay. Let's do actually I don't know what's the value. So if it's 1000, right, we do 31 at 31. So I think it's correct. So now we have the primes, right? Now what do? Now we need a priority queue, right? So we say import heap queue. Now heap is going to start with 1, and we say what? So prime square. Right? So heap is this. When do we stop? Well, we stop when while prime this, right? So we have a heap. Then we're gonna say temp is equal to this, right? And we're gonna say while true. So current small equal to heap q dot heap pop heap, right? So we're gonna say temp dot append. If a temp dot append this, right? So we pop it out, and then heap q dot heap push heap with push. So the current value. So current value is prime dot pop, the largest. So while current true, right? So temp, we're gonna pop the smallest, and we say if temp the smallest, the current smallest one, multiplied by current is smaller or equal to your limit, right? If it's smaller or equal to your limit, so the then we push this one in. Okay, so we push this one in, and then go back up again. So we're gonna pop the heap again, and then we do multiply. Else, once it fails, then we break. Right? So once it fails, so we pop out a new smallest one, and then we multiply, and it's larger than limit. Then we pop. So when we come out, we're gonna say heap dot extend temp and heap q dot heapify heap. So extend the temp, go, and then come up again. Right, and the last one, blah 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 blah, and then we'll heap dot extend, heapify, go up, prime q is out, so we're just gonna return the length of heap. Okay, so I don't know this. Let's try this. Oh, that was terrible. Okay. That is now correct. Let's go one by one. So what's wrong? Okay. How about let's do at the end. We'll just print heap at the end. And of course we'll have current. Current is 49. Heap is 1. What? What is your limit? Oh, that's n. That's not. That's n. Okay. Let's do all of these. Uh-oh. Okay, so if n is smaller or equal to 3, well, if n equals 0, return 0. If n is smaller or equal to 3, return 1. Okay? Okay, everything pass. Oof. The real question, the real challenge is given a large value, 3, 4, 5, 6. See how fast it can go. That is not how I'd expect. I got it wrong. Should be 1810. Oh, it should be 1000. I got 1810. But it's pretty fast, so maybe there's some hope, but let's see. Alright, so 1000 we have issue. Okay, let's fix this. 1000 supposed to be 31. I got 34. Okay, so first we check the primes. Let's check the print. Okay. Prime. 1000. Yeah, I think I did this. 1031. Right? I don't think this is the problem. What is the problem? Duplicates. Probably duplicates. Sorted. Yep, duplicates. Duplicates. Alright. How do we handle duplicates? I don't pen. Hold on, let me think. So we multiply, right? So we say it's multiply, then we push it in. The next round, we pop out, and we check if the pop out, because every time we pop out the smallest. So if the smallest is the same as this, then we don't do it, right? So we say current equals this, right? While true. If current is equal to temp, then break. Okay. If current is equal to temp, then we continue. Which means it's actually just if current is larger, it's not equal to, then we do this. If it's equal to, we just pop. Oh, hold on. It's not current. Hold on. No. This is popping out prime numbers. What happens is we pop this one out because every time it's going to be small, so we pop it out, and then we do the multiplication, and this is the same as the top of the. Hold on, let me think again. Oh. So on the heap, if this is the same, then we keep the, okay, so we can call it x. I don't know what to call. Right? So x equals this, and we say if x is not equal to temp minus 1, if it's equal, we just pop again. I mean, that just means, no, that's still not right. That's still not right. It's just, I come out, I just don't push it, right? I just don't push, I don't append it. So, hold on, so x equals this, right? So x equals this, and then I say if it's this, so we push it in. Right? If it's this, we push x times current. So if x times current is smaller than n, now we push it into the heap. We say if x is not equal to temp. So if not temp, or is not equal to temp dot append x. Okay, so if we go to this, oh, that is not right. Holy moly. Why would this not be correct? It's just x. So we pop something from the heap, and then we multiply. I will push this into the heap, and we say if not heap, or if x is not equal to, so x is the smallest coming out, so now we push it in. So what we try to do is to keep everything unique, right? This is my attempt at keeping everything unique. But why was some values? Would pop something out, right, from the heap. And then I compute this, because that's the smallest value, and I multiply by the current. And if it's good, I push this one in. And if this was not equal, so if this was equal to the temp, the last temp, then we don't append. Otherwise, we append. And we go back up, and we pop the next smallest, and do this again. Oh, the sag. What the heck? Let's do 10. That's 100. Alright, it's fine. Let's just see what heap is current. So current is 49. Heap is 1. Where's 49? Well, 49 is not pushed inside. Wait, this is weird. Have a temp. Current is 49, yes. X is to heap hop. X is 1. Say if 1 times 49 is smaller or equal to n, yes. Heap Q shall heap push 1 times potential push 49. If not temp, because temp is empty, so temp shall put 1 in it. Go up again. X equals heap pop. So heap pop. Now we're gonna pop out 49, and 49 has an as no, so we break. Oh, so that's why 49 is not in the temp. Oh. Huh. Why shouldn't we just put this one up? Will this one work? I think I tried this and it didn't work earlier. Yeah, this one works. Right, that's to avoid duplicates. Ooh. Are we saying we still have duplicates? Sorted. Keep. Yeah, we still have duplicates. Yeah, we still have. Alright, screw this. Like, seriously, screw this. I am not doing this. I'm gonna use a set. Yeah, seriously, screw this. So this is just gonna be temp minus 1. Temp minus 1, yeah, screw this. X is not defined. Of course X is not defined, there's no X. And X is not defined. Okay, so len set. There we go. So basically it's the same thing, right? It's the same thing. So we're not changing anything. We're not changing anything. We just say set. Alright, let's see. Yep. Submit. Booyah! We got this. Although the runtime is terrible, but we got it. That is the most important part. Alright, this is pretty hard. Pretty hard for me, but I'm pretty sure the actual solution will be 5 lines using some math. But my idea starts from realizing that for a value, for a number to have for the say ith bulb to be on, I must have odd number of unique factors, including 1 and itself, given an integer n equals to, let's say p to the a times q to the b times r to the c, where pq are prime numbers. The total number of unique factors are a plus 1 times b plus 1 times c plus 1. To make this value odd, we require that a, b, c must all be even. This means we can rewrite, this means the only value that can keep the bulb on is n equals to p squared, right? P squared alpha, p squared alpha q squared beta r squared gamma. Where alpha, beta, gamma are non-negative integers. Thus, we need to find all prime numbers, right, whose square is smaller or equal to the given n. Then we need to find all combinations of these prime factors, prime numbers, as factors to generate a value smaller or equal to n. I use the sieve to first obtain all the prime numbers. Then I use priority queue to obtain a sequence of numbers, a sequence of sorted numbers that all have the given prime factors. The final result is the length of this sorted list. Oh, I would say OM log m. That's what I think, right? Where, oh, actually no, because I think it's OM squared, because this is OM squared. Yeah, my guess is OM squared, where m equals to is QRTN. Run at 548. This is a tough one. 5%. Oh, so bad. 5%. Right. All right. 5 lines solution. Let's go. Math. I knew it. I knew it. One line. Jesus. What was the math solution? So basically just like count. You gotta be kidding me. A bulb ends up on if only if it is switched in odd number of times. Yes. Bulb 1 to bulb n. Bulb I is switched in round D if and only if D divides I. So bulb I ends up on if and only if it has an odd number of divisors. Exactly, that's what we have. Divisors come in pairs, like has divisors 1, 2, blah, 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 like set 1, I is a square. Let me read it again. The divisors come in pairs. Divisors come in pairs. Oh. Except for when it is a square. Oh. So we need to find out how many square numbers are. Oh. 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 So, how should I say this? We are close. We got the part that has to be odd number of divisors. Right? We're here. We're quite used to be even. I must have odd number of unique factors. Ooh. What a journey. I knew it. I knew it. I said 5 lines of using some math. Nope. The actual one is 1 line with just a little bit intuition. I am so close, but at the same time, also so far away. Yeah, exactly what I'm going to say. I am so close, but at the same time, also so far away from the official, not official, from the smart solution. I will link Mr. Pachman here. Upvote you. So I'm close because I also realized that to make a bulb stay on, the number must have odd number of factors. And then I proceeded to list all the prime factors and try to compute the total number of I will proceed to list all the valid factors right? To list all the values and try to compute the total number of values that can be produced by these factors. However, the smart intuition is that any value, any non-square numbers has even number of factors. The only value that has odd number of factors is square numbers. That is intuition. This is because factors always come in pairs, except when the number is a square, then the last pair has identical values. Thus, the problem is finding the number of square numbers smaller or equal to n. Turn int math.sqrt n. Not hint enough. I think this one should be hint enough. I guess if I do that, like 1 million, if I do the square root, I shall be able to see, but I didn't see. 31, yeah, it's like 10 that's squared, and 1000 square root, I didn't see. Well, people might not like it. I actually like this question a lot. A lot. Oof. Wow, we got 2 days in a row. 2 days in a row we have 2-hour session. Well, I just want to see how fast it can be. Square root, like 28, yeah. How does it look like, the whole distribution? Curious. But they still allow. I feel lucky that they still allow 500 milliseconds. All right, that will be it. A good journey today. I'll see you guys tomorrow. Adios.